You are watching Gabriel's online class. Okay, this online class, I personally decided to start this online class to reach out to those that don't know much about some certain subjects, and to also help myself to maybe read more and do some more research about some certain subjects. In case you don't know me, my name is Gabriel Miller. That's my picture over there, and the subject that I'm going to be taking you: mathematics, chemistry, physics, and introduction to project management. The topic is relative atomic mass and relative molecular mass. That's the topic. The relative atomic mass focuses on the average mass of one atom, while the relative molecular mass focuses on the average mass of one molecule. That's the difference. The relative atomic mass, from the name, you should know that it's talking about the average mass of one atom. The relative molecular mass, from the name, is talking about the average mass of one molecule. So that's the difference between the two. So let me go to the definition. The relative atomic mass of an element is the number of times the average mass of one atom of that element is heavier than 1/12 the mass of one atom of carbon-12. It is given by average mass of one atom of the element over 1/12 mass of one atom of carbon-12. In case you don't remember the definitions, you can use the average mass of one atom of the element over 1/12 mass of one atom of carbon-12 to remember the definition. Same thing with the relative molecular mass, but I'm getting there. Okay, the relative molecular mass of an element is the number of times the average mass of one molecule of that element is heavier than 1/12 the mass of one atom of carbon-12. It is given by average mass of one molecule of the element over 1/12 mass of one atom of carbon-12. You can also use that to get the definition. In case you don't remember the definition, you can use what it is given by to get the definition. The mass spectrometer is what is used to measure the relative atomic mass of an element. What is this relative atomic mass we're talking about? Like oxygen now is 16, nitrogen is 14, hydrogen is 1, carbon is probably 12. So that is the relative atomic mass I'm talking about, and it was all measured by a mass spectrometer. In case you're asked this in an examination setting, so you should be able to answer the question. So let's go straight to the calculation. The calculations for relative molecular mass. In case you want to find the relative molecular mass of something, or of a compound, this is how you do it. Number one, the relative molecular mass of lead-2-triazonitrate-5 is, you can see they put it, lead is equals to 108, nitrogen is equals to 14, and oxygen is equals to 16. Okay, they always put the relative atomic mass of the element you are going to need to find the answer of whatever you are given in questions like this. So in order to solve this kind of question now, we need to know the chemical formula for lead-2-triazonitrate-5. The chemical formula for lead-2-triazonitrate-5 is probably, in your mind you'll be thinking maybe it's PbNO3. No, that's wrong. It is PbNO3 into a bracket 2. So we'll say Pb, which is lead, plus 2 into brackets nitrogen plus 3 times oxygen. Remember, 3 is multiplying oxygen, but in 2 is multiplying everything that is inside the brackets. which is nitrogen oxygen times 3. Pb, which is lead, is 108 plus 2 into bracket 14. Nitrogen is 14 plus 3 times oxygen. Oxygen is 16. We should get at least 108 plus 124. So which is equals to 232 grams. So the relative molecular mass for the 2005 is 232 grams. Not so bad. So let's go to question 2. The relative molecular mass of ammonia. The chemical formula for ammonia is NH3. Most of us supposed to know that. N plus H times 3. Remember, H is multiplying 3. So now if I add my values, nitrogen now is 14 plus hydrogen, which is 1 times 3. 1 times 3, 3. So 14 plus 3 is equal to 17 grams. I believe you understand it up to this level. I still have some other topics to add to this one. For instance, percentage mass, molar mass. I've not talked about that yet, and empirical formula. I'm going to talk about that, but first I need to know your reactions to this video. I want to see whether you guys are actually interested in this video, or you want me to continue doing videos like this. Maybe you found this video helpful and you want more. I want to know how much you appreciate this video and whether you want me to do more.